Hi, Algebra 1 students. So we are in lesson 3. So f of x, this is in your books on page 39. Okie dokies. And so today for our learning targets is going to be define a function as a relation that assigns each element of the domain to exactly one element of the range, which means for every 1x, there's 1y. That's it. And we're going to write equations using function notation, or at least see them, and then determine and recognize characteristics of functions. All right, and if you look over here on the left-hand side, we have the warm-up, which was identify the range, the domain and the range of the relation described by each set of ordered pairs, and then we're going to write an equation that fits in those ordered pairs. Okay, so we're going to find the rule like we've done before. All right, and so for the first one right here, I've kind of highlighted those. Remember, the domain talks about all the values that x could be, and we just said it was going to be -3, -2. We just list all the x's, and literally if and we always put them in order, and this one happened to be in order, so from smallest to biggest. Okay, and if we do have repeats, then we don't repeat the number. It's already been taken care of. Okay, so in this case, this is what we would get. It's literally every number is different, so we list every single one of them, and they all happen to be in the same order, in the numerical order. So -6, -4, -2, 0, 2. That's going to be your range. All right, and we found that for me, what I like to do is I like to make tables or something that looks like this. So if I put in a -3, I get a 6. I put a -2, I get a -4. Right, this makes more sense. So if you guys can do with the ordered pair thing, go for it. Right. Just whatever makes sense to you. And so if we looked at this, we're like, oh, we're just multiplying by 2, right? Whatever this x is, we multiply it by 2 to get the -6 or to the -4, whatever the y is, right? And so we said that this is going to be, so y is equal to 2x. So whatever we do to 2, or whatever we do to x, we just multiply it by 2. I don't know if that just makes sense, but whatever x is, we're going to multiply that by 2 to get y. That's what I meant. All right, so if you look at the domain for number 2, right, it's all these ones with the arrows underneath, and we would write them all in order, in numerical order like that. And for the range, so you can list it out first if that helps you. And then what we're going to do is we're going to just organize it so that's from least to greatest. So we got 0 first and then 1. Even though 1 occurs 2 times, notice we just write it down once. We don't care how many times it happens, as long as, we just want to know which numbers they are. So 1, 4, and 0, 1, 4, and 9. That's it. And so we would not write our range like this. We write it like this. Okay. And then what we found out for this one, this is not number 3. This was for this top one right here. I made a little chart right here. We're like, oh, well, like if I go -3 times -3, that gives me 9. -2 times -2. If you notice the pattern here, it's just whatever the x is, you multiply it by itself to get the y. So it's x times x, which we know we can rewrite that as x squared. So this would be our rule. We like to make it the simplest way possible. So the least amount of writing possible. So, and then you look at the domain and range over for number 3 here. Again, we did not have any repeats, and they were all kind of in order, right? The domains, -3, -2, so on and so forth, and the range. Notice it starts with 3, but we want the smallest number first, so it's going to be -2, -1, 0, 1, 2. Okay, and if you notice right here, we're like, oh, well, x and y are like exactly the same, except one is just the opposite, right? And how do we say the opposite of whatever x is? It's just negative, right? So the negative of x, so just -x. Okay, and that's how that would work. And we talked about which one was different here. You can, think, okay, which one is the odd one out? Which one is the odd one, right? There's some reasons for all of these, so there was actually no wrong answer. And then we're going to review function, not a function, right? And this is basically review what we've been doing since we were in a different the packet, right? In a different book. So this is a good review. So we asked, what is a function? What is not a function, right? And if you look at this, see the highlighted parts. Do you see how we have x, the 3 for x, right? So one time we put in a 3, we get a -4. The second time we put in a 3, we get a 5. Okay, that's not a function, right? Even if at one point where you're not going to look at each point and go, is that a function, not a function? We're going to look at the whole set. Okay, and if at one point it doubles up like that, it's just not a function. If this looked like this, so if we had -2, 2, 0, 2, 3, -4, and 3, -4. Is this a function? Like, well, 3 happens 2 times. But I'm like, well, what's my output? Is it always -4? Yeah, both times it is, which means this one is a function. So that's fine. It doesn't matter how many times it occurs, as long as it gives you the same y value, you're fine. But here it does not do that. One time it's a -4, the other time it's a 5. So this is definitely not a function. If you look at this one, this is a linear equation, right? And all linear equations, except for the vertical ones, right, are functions. We talked about that yesterday, right? So this one's definitely a function. This one right here, the relation between students in your school and each student's birthday, right? So we said for the most part, if you're in America, usually you're going to be like, it's a function. But if you have like, see, for us in Korea, I'm not sure about other Asian countries, but for us, it depends. We can have 2 birthdays, right? What we can celebrate at 2 different times. One's our like our regular birthday that we would normally in America would consider, and then also you can have a birthday on your lunar calendar depending on what calendar you're using, right? So they actually have go by a different calendar, like the lunar one that's based off of the moon, right? The lunar calendar, right? And so if you look at a lot of those Asian calendars, they'll have like the regular numbers first, like the ones that we're used to, and then on the bottom they'll be, or on the side or somewhere, they'll be like in smaller numbers, a different date, right? Because that they're going by a different calendar. Okay, so that's what they go. I don't know what we call this calendar. I know the other one's called lunar calendar. I don't know what this one's called. So if you know, tell me. I would like to know. Anyway, so again, so depending on your point of view, you could say function or not a function. Either one would work. But I'm assuming from the book, they'll probably call this a function because they're like, when else would you be born? You're not going to be born twice, right? So maybe it's your when you were born, right? Because most people are not born twice. Not that I know of, not that I've heard of. And if you look at this mapping right here, and if you notice the highlight, you see at 4, it's definitely not a function. So this whole thing, because of the 4, it's all the 4's fault, right? Not a function. The whole thing is just not a function, right? If you look at number 5, remember the vertical line test, right? Where you take your straight line. All right, so this represents your value of x, right? So remember your value of x can only have one. For every x, there's only one y, right? So this is checking that. So if we had 2 points, we're across that 2 times, that means that that one x has 2 different values of y, right? So, and if you notice, yep, it only crosses once at any given point. It's a function, excuse me. And the domain, whenever you see a table, the way I like to do it is I look at the x's. Do I have any repeats? Nope, no repeats, which means for every x, there's one y. I really don't care about the y values. It could all be the same number. I don't care, because as long as the one x leads to one y, it could all lead to the same y, doesn't matter. But one x to one y, then we're good. Okay, so that is definitely a function. And then we did a little bit of skipping here because we already knew the thing about function and what that meant. And so here's function notation, right? And a few things to note. Okay, well, let's take a look at the scenario first. So the US shirts charge $8 per shirt, plus a one-time charge of $15 to set up a t-shirt design. Okay, so if you ever done like a group buying grouped shirts, right? So if you're, let's say sports, like if you're on the volleyball team and if you guys want to make a t-shirt, right? Then they always have like this base charge usually, right? Of like $15 or whatever to set up the design. So they have to prepare the printing, right? So that's that labor cost and plus the template and all that kind of stuff. And then once they have that template down, then they can start printing out shirts. And that's going to be like the cost of the actual shirt plus, labor costs and all that kind of stuff. So that's going to be $8 per shirt, right? And usually, if you order like 200 of them, then it's going to, it's like bulk price, right? You get lower, but we don't care about that. That is not here. So this is going to be our, we're going to set up the equation this way. So if you notice, we put an M here, because if you notice, it's per shirt, which means it's telling about a rate, right? So that's $8 per shirt. So that's our M. M is our slope, right? That's our rate of change. And then the one-time fee, anytime you see like a one-time fee, initial fee, that's going to be, or initial something, initial value, initial amount, that's going to be our B. I like to think of B as the beginning, right? Our beginning amount, right? I don't know why else it's B. And so that's going to be 15. So here, that's our 15. There's our M. So that slope is going to be multiplied by however many shirts we're going to buy, our x, okay? And so notice right here, this says f of x, and normally we would have put down y, but in function notation, our y is the same thing as f of x, okay? So if you notice right over here, our y is the same thing as saying the f of x. Notice this is not f times x, I wrote that right here, it's not f times x. We're not introducing a new variable, we're just trying to be a little bit more specific. So we were saying we have a function and it's dependent on whatever x is, okay? So this x is always our dependent variable, okay? And it doesn't always have to be x, it could be, if you look right down here, it could be s, it could be even m or t, or depending on what it is. You'll see t very often because t for time is usually our independent variable. And so this is just our output, okay, which we call also our y, okay? And so what we're gonna, let me write with this. And so here, this is our f of x. So again, they're just saying that this is the name of the function, okay? So we're just being a little bit more specific other than just saying y, okay, y, okay? And then if you notice right here, let's see here, and another thing that we talked about was, so if we said like f of 7, so what does that mean? That means, well, what would the output be if the x is equal to 7? And so we would literally, everywhere you see an x, you're going to put in a 7 and find out. So it'd be 8 times 7 plus 15. And you would figure that out, and that would be what your output is. So we would say this is 56 plus 15. Add those guys up, that'd be 60, 71. So we would just say f of x is, or f of 7 is equal to 71, which means if I buy 7 shirts, that's going to cost me $71. Okay, this is our input. This is our output. That's what the whole thing is equal to. F of 7 is equal to 71. Okay, dokies. Alrighty, let's go on here. Oh, and we talked about here. So we just changed it up. Remember, I told you that the f of x, that's just a name, right? So in this case, we're going to say that it's going to be c of s, right? To be a little bit more specific, c meaning the cost, given the number of shirts, right? So s means shirts. I don't normally like to write s for variables just because my s's look like 5s, and I don't know how to make it not look like 5s, especially on here. On if I can do it live, like on a whiteboard or something like that, I can make it look like an S. But here, see, looks like a 5. I don't know why. So the domain in this case is going to refer to the S's, right? And so what numbers can we put in here? You can put any number here, any negative number, positive number, 0. So what we can say, that's just all real numbers. And we'll talk more about domain on Monday. All right, and then on or you could say this, if we have these inequalities, you can say, oh, well, S could be anything from negative infinity to positive infinity. And the way we say that is negative infinity is less than S, which is less than positive infinity. All right. And notice it's always these less than signs. We don't do it this way. We go this way because we always talk about the smallest one first and then the biggest one traditionally. Technically, you won't be wrong if you go the other way around, but you just, yeah. It's like, what are the age ranges of the kids in your family? You don't say, oh, from 18 to 3. You say, oh, from 3 to 18, right? Normally we say normally most people say the smallest number first and then the bigger number. Okay, that's just how we do it. But you wouldn't be wrong if you do it the other way. But I'm going to recommend, please do it the small to the bigger. Okay, that's going to be our rule. All right, and same thing with the range. What are all the numbers that the range can be? Well, it could be, if the x can be anything, and there's no restrictions on that. We can go, if s is a very small number, like negative a billion, right? Yeah, I don't know why would do that, but negative a billion, then y is also going to be negative a billion, right? So this is going to be, again, the range is talking about the c of s, which is like our y, right? And this is, we can write it as all real numbers, or from negative infinity, oh, not s, c of s. Oh, that's not like a very good c. So c of s and to positive infinity. And the reason why we don't put equals there is because technically you can never reach infinity. Like infinity is a concept. We cannot actually reach it. All right, and some of you guys may wonder, well, why put in the real numbers? Aren't all numbers real? That's why you should have been in class. We talked about that, but we'll talk about this later on, I think. I'm pretty sure, I hope, right? But there are not real numbers, okay? But we don't call it not real numbers. They do have a name. So maybe you'll just come to class for that. All right. And then so, but in our context, in our situation here, what is the possible domain and range for the situation? Now, remember this is talking about, this is the domain here that we were talking about. I do not know why I didn't label that. And this is the range here. So if you notice, well, how many shirts can we buy? Well, we can say, we're going to buy no shirts. We just want the print, the template. Or maybe we had ordered it, but we're like, okay, we cancel that. They're like, no, you got to pay for the template, right? So then, so that the smallest number could be 0. We cannot order -5 shirts, right? You don't go call the t-shirt company and be like, can I order -5 shirts? They're going to be like, hang up. Okay, so it's going to be 0, 1, and you can only do increments of whole numbers, right? You cannot do like, can I have 2.7 shirts, please? No, you can't do that. But even if you tear it up, that's you don't do that. Don't be that customer, right? And then what is the range then? That's going to be, what's our smallest number possible? Well, $15, right? $15, and then it's going to be 23, 31, 30, 39. How did I get those other numbers? Well, remember, if we added 1 shirt, right? That's going to be $15 plus the $8, right? $8 that it costs for the shirt. So that would be $23. And then what if I wanted 2 shirts? Then that's going to be my 31. So you just add another 8. Just keep on adding 8 to this. Because technically in the world of no taxes, maybe we're in Oregon, right? Where they have no sales tax right here, right? So they're going to, yeah, we're just, there's no sense, there's no other numbers that we could possibly do. It's always going to be these numbers, okay? 15, 23, so that's the range. That's the reality of it. And it could go all the way up to as high as you want to go to. So that's why I put ... So I'm not going to do all that. And we talked about the vertical line test. We already did that. And discrete and continuous. Remember, discrete is basically literally only dots. You don't have lines at all in there, none. That's a discrete graph, okay? And a continuous one is where you can draw it without lifting up your pencil. Notice with these dots or points right here, you have to lift up your pen. You have to lift up your pencil, right? So that's what we call discrete. Continuous, you don't have to do it. You can do it in one fell swoop. Okay, dokies. And and this is a function, not a function. This was just showing that. Do you see how it crosses at these 2 points in this vertical line? Yeah, not a function. Not what we're going to do here. We're going to look more for the functions here. All right, and we're going to go on. We remember right here, we were talking about whether these were functions or not functions, and you were supposed to do that. And I'll just go over this right now. So if you look at A, where's my vertical line? I'll just make a vertical line. We'll use that as our test. That's vertical line-ish, kind of, sort of. So if we take a look at this, and we're like, okay, here we go. Does it cross more than once? We're like, nope. So that is going to be, so we got A as a function. What about B? Yep, B works too. What about C? C works too. What about D? Oh, no, D, many different points, not working, right? So we're going to go, it was A, B, C, easy as 1, 2, no, I'm just kidding. So D is here, not a function. And then we're going to go, let's try E. So notice right here, we have some, maybe you guys cannot see very well. I'll make it a little bit bigger for you. So if you notice right here, oh, it's close, but no, it only hits each point once, right? So that is definitely a function. It kind of looks like wouldn't be, but it totally is, right? And then if you look at F, definitely straight line. Yeah, there's no contest on that. So this one too, again, this is a function. So these are all functions so far. And what about, I'm going straight to M apparently, and N. Yep, this is definitely a function. So all of these guys are functions. So we're going to say that was E, F, M, and N. All right. And we're going to go over here. We're going to just scroll down. I'm going to just finish these guys first and then go to the side. And we're like, vertical line. Yeah, that's definitely not a function. Okay, so O is not a function, but P is and Q is. Usually instead of making this line, I use my finger to kind of go across, right? And so O's not a function, but P and Q are. So it looks like we have a lot more functions than we do not a function, right? And then we're going to go over here. Move it on over. And it looks like right here, G, do we have a function? Yep, G is a function. H is a function. I is a function, any given point. Yep, I is a function. J is a function. This is actually called a parabola. You guys will talk about that in algebra 2. My algebra 2 kids are talking about that right now. Right, so all those 4 functions, but this guy, see, broke it right there. And this L is definitely a function. Okay, so it's just everything but K. So G, H, I, J, and L are all functions. So we're going to say G, H, I, H, I, and then J is over here. And then, wait, what about K and L? Oh my goodness, I forgot. Oh, the K is the one that's not a function. Got it. Not J. You guys are probably already knew that. You're like, no, it's not that. I, J, K, and then L. There we go. So those are not functions. And that is the end. And we're going to talk about our domain and range next time. I will talk to you guys later.